Okay, so we're going to look at actually how to use the unit circle when doing problems. So let's go ahead and get started. Okay, so before you can learn how to use the unit circle, you have to know some important information. So probably the most important is the cosine over theta, the cosine of theta over the radius, and the sine of theta over the radius. So this will be our x value, and this will be our y value when we're looking at points. So then the tangent is the sine of theta over the cosine of theta, and you just have to memorize that and know it because that is very important right there. So then the cosecant is the reciprocal of sine of theta, which is the same as 1 over sine of theta. So if our sine was 3/4, we could say our cosecant is 1 over 3/4, which is the same as saying 4/3. Okay, so our secant is going to be 1 over the cosine, which is the same as the reciprocal again. And you have to remember cosecant goes with sine and secant goes with cosine. Those are very easy to get mixed up, but don't get them mixed up because then it's wrong. So then cotangent is just the reciprocal of the tangent, and that's pretty easy to remember because it's cotangent and tangent. Okay, so this is also pretty important. The equation of a circle, it will be x squared plus y squared equals r squared, where r is your radius. So if they gave us a point 4, 5, to find the radius, which is what we're trying to find, we take 4 squared plus 5 squared and set it equal to r squared. Then this equals 41 equals r squared. Take the square root of both sides, so the square root of 41 would equal our r. Okay, so let's get started in with some problems. So it wants us to find the 6 trig functions of 2 pi over 3. So 2 pi over 3 is right here on the unit circle. And I'm going to go ahead and write out the 6 trig functions, which is the sine of 2 pi over 3, the cosine of 2 pi over 3, the tangent of 2 pi over 3, the cosecant of 2 pi over 3. And it's easier if you write the reciprocals across from each other. So I'll write the cosecant across from the sine so I don't get that mixed up, and then the secant across from the cosine, and then cotangent 2 pi over 3. Okay, so now if we know that our radius is 1, that means our points are going to be cosine of theta over 1, sine of theta over 1, which is the same as just saying cosine of theta, sine of theta. So our first point is going to be our cosine, so that means our cosine of this is negative 1/2. It's just as simple as that. So then our sine value is going to be the second value, which is also the y value, which is going to be the square root of 3 over 2. So our sine is the square root of 3 over 2. Now our tangent is going to be our tangent of 2 pi over 3 is going to be the sine of 2 pi over 3 over the cosine of 2 pi over 3. That means we're going to put the square root of 3 over 2 over negative 1 over 2. Now this looks very complicated, but really this is just equal to the square root of 3 over 2 times negative 2 over 1. So then the 2's cancel. You have to keep the negative. So then negative square root of 3 is going to be our tangent. So then to find the cosecant, you just take the reciprocal of the sine. So we're going to take 2 over the square root of 3 and rationalize it and multiply by the square root of 3 over the square root of 3, which gives us the 2 square root of 3 over 3. So then we're going to take the secant and flip that, and the reciprocal of negative 1/2 is just negative 2. And then the tangent of this, we're going to take the reciprocal of that to get the cotangent, which is going to be 1 over the square root of 3. It's a negative. So then multiply it by the square root of 3 over the square root of 3. We're going to get negative square root of 3 over 3. So it's just that simple. So now let's look at one that's a little bit more difficult. Okay, so it's going to ask us to find the exact value of sine 45 degrees times the cosine of 180 degrees. So on here, let's find 45 degrees and 180 degrees, which is right here. Okay, so the sine of 45 degrees, so if we know cosine of theta and the sine of theta, so the sine of 45 degrees is going to be this right here. So we're going to take the square root of 2 over 2 and multiply it by whatever the cosine of 180 is. So the cosine of 180 is negative 1. So we're just going to take it, multiply it by negative 1 over 1, which will give us negative square root of 2 over 2. So that is probably the simplest thing. Okay, let's go to the next one. Okay, so this is asking us to find the 6 trig functions of theta if the terminal side of theta intersects the point negative 3, negative 4. So I'm going to go ahead and write out our 6 trig functions that we're going to be filling in, and their reciprocals are across secant of theta and cotangent of theta. Okay, so the very first thing we need to find is the quadrant that this is in. So this is going to go through negative 3 to negative 4, which is right here. So the terminal side of this is going to be right there. So that means it's going to be in quadrant 3, and everything's going to be negative except the tangent and the cotangent. So we can go ahead and put that in. So now we need to find the radius. So to find that, we do negative 3 squared plus negative 4 squared, and I'll put these in parentheses, equals r squared. So that's 9 plus 16 equals r squared, which is 25 equals r squared. Take the square root of both sides. Our radius is 5. So we can just plug that in right there. So then knowing the cosine of theta over r and the sine of theta over r, we know up here this is the sine, this is the cosine of theta, sine of theta. So what we can do is take this, put it over that, and this, and put it over that, and we have really 4 of our values. So the cosine is going to be negative 3/5. The secant is going to be negative 5/3 because we just take the reciprocal. The sine is going to be negative 4/5, and the cosecant is going to be negative 5/4. So then to find our tangent, we just take negative 4/5 and put it over negative 3/5, which is negative 4/5 times 5 over negative 3. Cancel the 5's, we get 4/3 as our tangent. And then the reciprocal of that is 3/4. So this is really pretty simple. It looks very complicated, but in reality it's not. So that is how you use the unit circle to help you solve problems.